earthquakes, they are frequent. 80% of the earthquakes and volcanic activities, they are surrounded, uh, surrounding the circum-Pacific belt, which is called the Pacific plate. Surrounding the Pacific plate is called circum-Pacific belt. More than 80% of the earthquakes. Rest 15% is concentrated along the Himalayan Alps, that is called the Mediterranean Asiatic belt. And rest others, only 5%, they are within the plates. So within the plate, earthquakes are not very harmful, but the Kutch earthquake, which is within the plate earthquake, that is a devastating earthquake. And that is why the importance of the Kutch earthquake was very great amongst all geologists. Put aside all activities, because this is very long processes and very elaborate processes of the volcanic activities. Volcanism is also one of the evidences of how the earth is actually breathing. So I have given you a small example of the Deccan volcanic activities. Around 65 million years from today, there was a big activity, not one day activity, but it lasted for almost 6 to 7 million years. That activity, volcanic activity, has given rise a long Deccan plateau. When you move from Mumbai to Pune or Amarkantak, you can see the ghats, and these ghats are having parallel layers, which are all basalt and other volcanic rocks. This entire plateau is made up of the volcanic rocks. So there was a huge eruptions, that is called the reunion hotspot eruptions. Now we move to the other phase of the lecture, where we are now on the Earth's surface. How lithosphere developed, how hydrosphere developed, we talk much about it. How atmosphere developed, we talk little about it. But how anthroposphere developed, we have not talked about. How biosphere developed, these are all big events, and which itself is kind of a big course. So I just mentioned that entire Earth is made up of several spheres, and they are all moving, they are all dynamic by itself. They have interactions with each other. Hydrosphere has interactions with the lithosphere. Pedosphere has interaction with the biosphere and hydrosphere. Every sphere has interactive properties, and that is very important to know. Now, as we talked about the endogenic processes, which is earthquakes and volcano and many other small events, there is another process which we are now focused upon, is exogenic process. That means the energy which we are receiving from the others. That means not other, sun is not other, that is our father. Do you know that endogenic processes by which we are live in the sense the plates are moving, that also is inherited energy. It is inherited from the sun. So we are using, the earthquakes are basically the inherited or remnant heat, residual heat since 4.5 billion years, and it is dissipating today. It is we are losing it today through the earthquakes. Every earthquake, every volcano, that will, it is dying our earth. Now, see, the other phase of the lecture is exogenic processes. Exogenic processes also gives you the sun gives us the energy, and it makes the climate. So the role of climate in the shaping the landscape is very important, and that in that sense, Earth is also dynamic. So look at how big events through which big events the Earth changes the landscape. The major one is a flood, cyclone, and tsunami, and many other slow erosion processes, which we are going to discuss today in the second phase of lecture. Look at this vast young mountain chain, which is known as the Himalayan mountain chain. And below it is a flat Ganga plain, and below the Ganga plain or Indus and Ganga plain, we have old mountains. Out of them, you can see a one line, which is Aravalis, around 2.5 to 2.9 billion years old Aravali mountain chain. This is the oldest in India. There is another mountain chain, which is Nilgiri, Eastern Ghat, and the Dharwars. So these are all old tectonics, which are, I'll discuss not much about these tectonics, but the major issue, which is that this is young mountains, and that has influence on our life on the plane, making the plane, and all life which breathe during the human era, that means last 5 lakh years, to the civilizations. That means Indus Valley civilizations to the Vedic civilization in the Ganga plain, all are affected, and they are influenced by the latest erosional or climatic and tectonic processes. See, my point of focus over here, that these tectonics are uplifting the mountains everywhere, and the climate which degrades the mountain. So this is the idea of all rest of the maybe 10-15 minutes. Look at this picture where we have old rocks, 1.9 to 2.9 billion years old Archeans to early Proterozoic rocks. They have sediments, they are sedimentaries and metamorphics. Here you have 2.3 billion years old banded iron formations. Just remember this banded iron formation, because I am going to talk to you about something important of this, because I just want to show you that this banded iron formations is the later period. But 2.3 billion years old stromatolite, or the cyanobacteria, that has gave the oxygen to on the earth. When oxygen came in the atmosphere of the Earth's atmosphere and the oceans, then everything starts, because cyanobacteria is responsible for the oxygen sphere on the Earth. But who used the all oxygen, initial oxygen on the Earth's surface? This banded iron formations is the evidences of how the rocks or the earth processes, they used the oxygen. The oxidation process, iron oxidation processes, that actually started something around 2.3 billion years from today. And after that, oxygen was used. Again, how bacteria gave the oxygen. So these are all biological and biogeological and geobiochemical processes. It is a big domain by itself. In 1 hour, I may not include all these talks. Look at some other pictures, younger pictures. 350 million years old Paleozoic limestone rocks. This view photo I have taken in South Africa, near Cape of Good Hope. 170 million years old Kutch, Jurassics of Kutch. Why I am mentioning that, you will come to know that the dynamism of the earth, this will give you the dynamism of the earth. So after the advent of the oxygen, after the advent of the cyanobacterial life, one cellular life to the multicellular life, then there is an evolutions, and slowly and slowly, but for several millions of years, several billions of years, from 2.3 to 590 million, 2.3 billion to 590 million years, there was no hard skeletal life. So we could not have any skeletal remains, and we know not much about the early life than 590 million years. But you can see these pictures where several organisms, I have shown several organisms from the early 590 million years trilobite life to the Jurassic life ammonites, how ammonites were moving in the Jurassic oceans, and same time how dinosaurs were moving on the continent. And here a big skeleton of the Ichthyosaurus marine reptile is discovered. How? Okay, so look at this Archean life to the Paleozoic life to the Cambrian, Ordovician, Silurian to the Mesozoic life. So this is the chain. I am not going to discuss much upon the life form and their evolutions, but human came last in the Quaternary period. As sir introduced me that I am the man of quaternary science. So we are working just last 2.6 million years to zero. That means from present. We are not working from 4,500 million years to 2.6. This is not of my domain. But when man came, before that, before the man came. So this is very important period. We are not here to give you the clear all evolutionary pictures, but I want to show that biologically, the earth since the beginning or since the advent of the life till today, it was so dynamic and it is still dynamic. I give you one small example. If you see, this is a today's picture, present day sand ripples on the Kutch coast. And here, this is 170 million years old Jurassic ripples on the sandstone. So present is the key to the past, or past is the key to the present. We call in geology, it is called the uniformitarianism principle. But uniformitarianism principle gives you the slow erosion, slow depositions, and all slow processes. Whatever we are now move to the how Himalaya formed. As I told you in the earlier picture that how Himalaya formed and how they have changed the entire human dome, entire civilization, entire new domains. Now we come to know about the tectonics. If you can see the mountain chain, here there is a clear-cut demarcation of the boundary where there is a mountain ants and the plain region starts. This is very common in all Himalayan roads. When it enters into the Himalaya, these are very common features. The idea behind this picture is this part is tectonically uplifting and tectonic forces are uplifting this mountain, and climatic forces, they all the time degrade these mountains and they make the sediments downstreams. In this picture, I want to show you about the young glaciers. If you can see the youthful glaciers and glacial topography after the Himalayan adventment. This picture is taken by me while I was flying from Delhi to Leh. So it is around Leh or a little bit away from the Leh. You can see very good glaciers. These glaciers, they are basically source of the water as well as source of the erosion, and this erosion will give you the all Ganga plain and everything. So this is the major driving force of the civilizations. The climate, so with this you can understand the climate has major role in carving the landscape. Some more picture of the glaciers. You see some glaciers, 1, 2, 3, 4 glaciers, they come together and make a large glacier. Okay, so this is a famous glacier, widest, longest glacier of India. This valley, these glaciers move slowly and slowly, almost few feet a year, and they erode the valley. And what actually they put behind is a zigzag topography. Look at this zigzag topography. And look at the last 20,000 years old glacial maxima to the interglacial period. So in the glacial period, which was 20,000 years to 18,000 years, it was glacial period on the Earth's surface. Entire Earth was temperature was very low, and these glaciers you can see at very rear corner. They were all these valley were all valleys were studded with the glaciers, and these glaciers are receded slowly and slowly. This gives you a picture, a very good downstream plains and life to all people on the Earth's surface. This picture will give you the how glaciers are. The snout is done. This is the snout. This is the only glacier in India which you can touch the snout just parking your car somewhere, and just by walking half a kilometer, and you can touch the snout of the glacier. That is Prakachik Glacier. This was the picture of one of our field programs, BST sponsored field program. Now, the glacier when recedes or advance, they put behind a large valley, and this is called the U-shaped valley of the glaciers. And this topography is called the zigzag topography. So this is why I am showing it to you, just to show the glacial erosion. And this is very important for the downstream all dynamic topography, because here the vegetation is sparse. There is not much vegetation entire year, but there is only erosion. So these people over here, they are withstanding the erosion processes, withstanding the life without water, but giving the life to the downstream people. So this is it's a kind of conflicts in Himalayan regions, mostly in the higher Himalaya to the lower Himalaya, it is a conflict. I will skip those slides because this will give, this is the same picture how in the Leh, this is Indus Valley. And you can see the latest fan development. So these are all quaternary deposits, but these are all Paleozoic deposits around 500 million years. And how the landscape is degrading through tectonic uplifting and incisions. So this is also the same Indus Valley. So my simple idea to transpire to you is the tectonics is uplifting the mountains or the landscape, but the climate is degrading. This is the core idea of this particular sections. Now, we are moving slowly and slowly from Leh to the downstream side. Here in the Leh, you don't see any vegetations, while here you can see lush green jungles and valley full of the vegetations. Because it gets the water. There is no ice, but water that makes the pedosphere, that makes the soil development, and that gives you the life. Greener, slowly and slowly when you go to the south, and when you leave the Himalayan mountain, you have the endogangetic plains, vast endogangetic plain, and that is the huge. Why I have given the plus, because the sediments are increment. Okay, in the Himalaya, plus means the glaciers, this plus in Himalaya, higher mountains, it is upliftment. That means the energy is given by the internal heat and it uplifts the mountain. Here plus is due to the sediments it receives. And there are some other pictures of the Meghalaya plateau, which is also very young, few million years old Meghalaya plateau that is fastly uplifting mountain. Now coming, Professor Hitesh, is it okay? Should I move further? Our last phase?
Yes, you can continue some more for some more time.
Okay. Okay. So now coming down to the young features of the Kutch. Why I am Kutch? Because it is maybe because most of my research is concentrated in the Kutch, and I have explored much the Kutch landscape, and landscape is my passion. You see, the Kutch landscape has very sharp boundaries. These sharp boundaries are basically depicted by the fault systems, and they are all active faults. These faults are active faults through which the landscape is uplifting. And this vast desert, or it is called the Run of Kutch, it is active basins. It is not active seismically, but active basins where the sediments from all the sides are depositing, and we call them the factory of the rocks. So that is more than 500 meters of the sediments there inside the run grabens. My point of uh, to mention over here is how tectonics in this particular landscape has made changes on the landscape. This line, my cursor, you can see the cursor line of the small uplifted terrain is Allahabad. So one earthquake just 200 years from today, that is called 1819 earthquake, has made a long ridge in the vast saline flats or the saline lands or the Great Run of Kutch. It has uplifted by 6 meters of the land, and that has changed the total topography and demography of the area. So that is what my um, uh, uh, focus of today, that the how dynamic the earth is. You can see the 200 years old earthquake which has changed the topography. 2001 earthquake, I have some photographs of 2001, just 20 years old earthquake. It has also changed the topography, it has also changed the demography, it has changed the many things, but we are not much concerned today about the human psychology. But let us look at the 1819 earthquake, the effects of the 1819 earthquake. Once upon a time, this river, Nara River, was a flourishing river, and big ships were moving through this river. Now it is desolate part of the run, uplifted part of the run. And surrounding part, you can see small gullies and valleys. They are all young, 200 years old rivers. So there is a new streams are developed. This is very important for those who are working on the young geomorphology. This is young geomorphology, just 200 years old geomorphology. Before that, it was just flat terrain. And this is that particular river, which is now desolated. This is the way to Pakistan. So you go to the north, there is some of the ports in the Pakistan were there, and ships were moving during the princely state in Kutch. Some of the pictures I am sharing with you about the Allahabad terrain. Now look at the 2001. 2001 earthquake has also made the small scarps. Of course, it is very small compared to the other earthquakes. If I talk about the Chichi earthquake in Taiwan, it has actually uplifted the surface by more than 8 meters. And but I don't share those pictures over here, because then let us look at some of the major features developed during the earthquake, 2001 earthquake. These are my students worked under me, and this valley today and this March 2003, if you can compare this valley and this valley. So the earthquake is how an earthquake changes the landscape. So small stream which you see today may be the consequences of the large earthquakes. So you can see 100 years of tectonic changes. You can say 100 years, you can say 1,000 years, and you can say like this 1,000 years, because this particular sediments we have dated is 5,500 years old, and just near Dholavira town. And when Dholavira people were here, or Indus Valley civilization people were here, this particular sediments was not here. So how the climate also, because this is fluvial deposits, so climate also changes the landscape and how they make the planet so dynamic. And this is some remains or some remnants of our old civilizations, which is considered as the very wisest civilization, Indus Valley civilization. Some groundwater, how to store the groundwater, the drainage systems, the reservoir systems. They had fantastic systems in this Dholavira town. Okay, why I'm mentioning here that the man is also one of the element in the dynamic planet. Okay, look at some pictures where dynamism is very much seen. This crack is not very old, very in geological sense, maybe 50,000 years. So we are dating these particular locations through many different methods in physics. And this is blah blah. All kids, dynamic kids are jumping on the dynamic planet. Thank you very much for your kind attention. Thank you, sir.
Yes, sir. Thank you so much. Now, sir, we can take the question and answer session.
Yes, yeah.
Yeah, so those who have questions, just raise your hands and we will allow you.
Is there anybody who
Yes, there are many, sir.
need
One,
interested to ask the questions?
yes, there are many, sir. One person named Limbani Ajay.
Hello, sir.
Yes, yes.
सर आई एम अ फिजिक्स स्टूडेंट.
Okay.
सर मुझे क्वेश्चन ये है कि हमारे देश में और विश्व में बहुत सारी माइंस एक्टिविटी हो रही है.
Okay.
तो हाँ, तो माइंस एक्टिविटी में सबसे पहले माइंस क्लोज करने की प्लानिंग होती है. तो माइंस बंद तो हो जाती है, पर उसमें से जो मेटल और ये मिनरल्स निकाल लेते हैं, तो उसकी वजह से जो पृथ्वी के मैग्नेटिक फील्ड में कोई असर होता है या नहीं होता है, और होता है तो किस प्रकार से पृथ्वी को नुकसान करता है. थैंक यू सर.
मैग्नेटिक फील्ड, पृथ्वी का जो मैग्नेटिक फील्ड है उसका मेजर रीजन उनका सॉलिड कोर है, जो आयरन और निकल से बना हुआ कोर, वो उनका मेजर रीजन है. जो ऊपर जो छोटी छोटी माइंस है, द स्मॉल माइंस इन द अर्थ क्रस्ट, that are infinitesimal, that has no value in front of the major magnetosphere and our magnetic property of the earth, because the earth crust is very small in terms of the entire giant magnet which is lying below. So there is no, because it is a very local phenomena. It is not actually 1% of the entire earth mass, not 1%. Okay.
Okay.
Yes, sir.
But sir, depth of the mining activity is 50 to 70 meters. Sometimes it's 100 meters. That means 0.1 kilometer. And average of the radius of the earth is 64 kilometers. That means 1% of the radius we are just digging it. Then
no, radius of the earth is 6,371 kilometer.
Oh, sorry, sir.
6,371 kilometer. The deepest mine in India is a Kolar mine.
Yeah.
And that has gone up to 12,000 feet, I think. 12,000 feet. So it is also 1 or 2 kilometers.
Yeah.
But it has of no much influence on anything except the human sphere or anthroposphere. हम जो जीते हैं उनमें कुछ प्रॉब्लम आता है, कहीं सिंक हो जाएगा. हम पेट्रोलियम निकालते हैं तो कहीं बड़े बड़े सिंक भी हो जाते हैं. हम ग्राउंड वाटर निकालते हैं तो उसका इम्पैक्ट लोकल होता है. लेकिन जब आप सोचोगे पूरी पृथ्वी के बारे में, तब इनका कोई वैल्यू नहीं है.
Yes, sir. We have a next question from Gaurav Prajapati.
Yeah. Hi, Gaurav.
Hello, sir.
Hello.
Hello. So my question
is
is
Shiva in your, okay. Huh.
Hello.
Yeah.
Yes.
Hello, sir. Since the motion is relative concept, what is the reference point for calculation of different motions of Earth, like rotational or orbital motion?
Rotational motion of the Earth, or the which motion you are talking about? It is related to Earth, whatever we measure. Hello, Gaurav, can you hear me? Hello, Gaurav?
Yes.
Whatever motion you measure on the Earth's surface, it is all related to the Earth. Simple.
Yes, sir. Now
if I say that Earth is moving around the Earth, Sun, so that is also relative. Okay, whatever is that, everything is relative. You are the student of physics, you know much better than me that everything is relative. If you go and change your position to other planets, your change or measurements and everything will be changed.
Yes, sir. Now we can take the next question from Nita Beshid.
Hello,
Yeah,
morning, sir.
good morning.
I would like to ask you that how much scope physics student have in the field of geology?
How the physics scope? There are ample scope. In my talk, Neetaji,
Yes, yes, sir.
can you hear me?
Yes, sir.
In the beginning, or maybe in the middle of the talk, I told you about the physics has major influence on geology today, because not a single rock is analyzed without the help of the physics. My XRF analysis, X-ray fluorescence spectroscopy, X-ray diffraction spectroscopy, then OSL, optically stimulation luminescent dating methods, EMS dating methods, many things. We are now crippled without you.
Okay.
Yeah.
Yes,
So I
sir.
cannot give you each and every example that physics is responsible. If I want to go for the geophysical, to find out what is below the surface, I must give your advice. Geophysical methods I have to use. There are several geophysical methods.
Yes, sir. We have a next question from Ajay Majetia.
Okay. Yes, Ajay.
Hello.
Yes, I can hear you, Ajay.
Sir, during the earthquake, hello?
Earthquake.
During the earthquake, P and S wave are produced, or hello?
Primary and secondary waves, they are produced during the earthquake at the moment of the earthquake.
And how can we distinguish if P waves are produced or S waves? Any detector is there, or?
Yeah, if you have the seismogram with you, or if you go to the laboratory, seismic laboratory, you can find out the first wave which comes, the strong wave, P wave comes. That is the first wave. Otherwise, after that, some interval of time, few millisecond, the second wave will come. So they seismologists generally, you physics people generally can understand the characteristic of the P and S waves, but they can be distinguished with the help of the receiving points at the seismogram. Yes.
Chintan, I would like to ask one question to sir.
Yes, sir.
Chintan, can I ask one question right now?
Sir, bolo, sir.
Sir, would you please explain what is tsunami and how it is produced, and which wave is responsible for the tsunami? For the benefit of
tsunami is basically, sir, can you hear me?
Yes, I can hear you, sir.
Tsunami is basically a submarine earthquake.
Yes.
The earthquake when comes on the continental part, which we can feel and see, like what I explained about Chichi earthquake or Kutch earthquake, Bhuj earthquake and Allahabad earthquake. But the earthquake which displaced the oceanic plate and produce tremendous energy and produce the P and S waves that can generate the energy, that can dissipate the energy within the ocean, and from that energy which produce the large waves, but that wave has a very low amplitude.
Yes.
Okay, 2004, 26 December 2004, there was a huge tsunami developed due to the Andaman Sumatra earthquake. So it has displaced around 7 to 8 meter of the Indian plate down the Burma microplate. Hello?
Yes, sir. Yes, sir. I can listen. Yes, sir. Yes, sir.
Yes, sir. We can follow you, sir.
There is some problem with his audio. Chintan.
Just a minute, just a minute. There is some connectivity error. Sir is just coming.
Yeah, no problem.
Just a minute.
Yeah, no problem.
Yes, sir.
Maybe his internet connection is having some problem.
Hello.
Yes.
Uh, hello. Yes, sir.
Uh,
We have a Professor Mahesh sir online. So there is some problem in the
Yes.
connectivity. So sir will continue in this. Sir will speak and we can listen to them. Yes, sir. Please continue, sir.
Yeah, yes, sir.
Yes, sir. Continue, sir. Mahesh sir, you can continue.
Regarding the tsunami.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Vora, sir. Hello.
Yes,
So I was explaining you about the 2004 tsunami event. Actually, during that period, I went there after 3 to 4 months, and I have recorded many ground deformation movements. But when there is a submarine earthquake, it creates a huge wave. But that low amplitude, maybe a few feet amplitude wave, that actually travels with a tremendous speed, maybe around 900 kilometer per hour speed, to all the sites in the oceans, and that when it hits to the shore, that will create the tsunami. Okay, so when the thick pile of water, which is around 4 kilometers of water, which actually moved with this wave, and when it hits to the shoreline, where the thickness of the water or depth of the water is very low, so that the wave breaks and it actually engulfs entire shore. So that is called tsunami.
Thank you, sir. Thank you, sir.
just a minute.
And thanks for a wonderful lecture, sir. Wonderful lecture, sir.
Sir, now we would like to present a vote. We would like to present you a vote of thanks. For that, now I invite one of our research fellow and PhD scholar at Department of Physics, Miss Hardika Goswami. Just a minute. Yes, please.
Good morning, all. Hello, can you hear me?
Yes.
Yes, continue.
Honorable Vice Chancellor, respected Pro Vice Chancellor, and today is our special guest, Professor Pratap C. Chauhan, sir, Professor Pankaj Joshi, sir, Professor Pankaj Gajjar, sir, Dr. Mehul Rupani, sir, Professor Mihi Joshi, sir, Professor Hiren Joshi, sir, Professor Nayan Jain, sir, and all participants. It is my privilege to have been asked to propose a vote of thanks on this occasion. Myself, Hardika Goswami, on behalf of Anusandhan webinar on research methodology and frontiers in science, jointly organized by Department of Physics, Saurashtra University, Rajkot, Gujarat Science Academy, and Essence Tech, entire organizing team, and my own behalf, extend to a very hearty vote of thanks to all. A big thank you to Professor Dr. Mahesh Thakkar, sir, for gracing your important work and sharing with us your findings and opinions today. I must mention my sense of appreciation to sir for giving an excellent coverage of Earth as a dynamic planet, as well some knowledgeable topics like atmospheric revolution, plate tectonics, as well the physics of earthquakes and so many more things. And thank you so much, sir. We are all inspired by your great words, sir. And finally, I would like to extend my thanks to Professor Nikesh Shah, sir, Professor Nayan Jain, sir, Dr. Tushar Pandya, sir, and Mr. Chintan Panchasra, as well, all the PhD scholar for their enormous cooperation in the organizing of this event. And thank you all attendees of this seminar. Thank you so much.
Thank you. Thank you.
So much, sir. Now,
Yes, sir. Thank you, sir. Thank you. Thank you. Now I am connecting. I am.
Yes, sir, sir.
sure, sir. You can, sir.
Sir, it was a wonderful lecture. Very
See
interesting, very
you.
informative, sir.
Same password, na, sir?
Same, sir. Just a minute.
Thank you, Harika.
Once
Just a minute.
again.
Actually, my computer is
Yes,
just.
Okay.
Yes, sir. Your voice is available.
Yeah. Can you see me or hear me?
Yes, sir. We can you, sir. Thank you very much for very interesting, informative lecture, sir. Wonderful lecture. Wonderful lecture.
Thank you, everybody. Thank you, everybody.
Thank you, sir. Once again, we thank you so much from all the organizers, and we thank once again. Thank you, sir.
Okay, bye. Thank you. Good
Thank you,
day.
sir. Bye,
Have
sir.
a good day, everybody.
Good day.
Thank you.